We have built a recommendation system for songs and artists. The recommendation system takes a user profile containing ratings given to a number of songs and artists by the user. The recommendation system, based on this information, presents the user with a number of new songs and artists that the user is likely to enjoy. The machine learning aspect of this system was built in Spark. The front end was built in Django, and the data was handled in a PostgreSQL database and by Spark SQL.
Okay, so this is our recommendation system for artists and songs. So what we did is that we created a Spark recommendation model for songs and for artists. So if we go to, for example, artists, then we supply a user ID. And for this user ID, we are returned with this amount of user ratings. And we can see that this user has rated Aerosmith 90, for example. And based on these ratings, we used Spark to create a recommendation model, which gives us predicted ratings of other artists. And the idea is that based on our ratings on artists, they can pick out artists which are most similar to artists that we rated with a high value. And therefore, according to our Spark model, Gem is the best match since it has the highest rating here. And the model also has a mean squared error, which indicates the accuracy of our predictions. And for songs, we have a similar setup that we supply a user ID and we are returned with user ratings, but this time for songs. But the limitations of our dataset was that we couldn't identify the actual song names, nor always identify the genre, as you can see. So there were some troubles with trying to verify that these predicted ratings are in fact similar to those that we rated with a high value. But we can see, for example, here for this user that songs which are of the genre R&B were often rated high, because here R&B is 5, and here we can see R&B 5, R&B 5, and that makes it likely that the songs that we are recommended with in turn are also of the genre R&B, and therefore it seems actually like a valid recommendation.
Okay, now to look a bit under the hood of how our recommendation system actually works. A recommendation system is basically a machine learning technique, and like all machine learning techniques, we need data, which in our case was provided by Yahoo Music. It was 2 files where it basically was compiled user ratings for different songs and different artists. And the specific technology that we used in order to create this was called collaborative filtering. It is basically a probabilistic approach to user rating prediction, and that basically means that it aims to fill in the missing entries of a user item association matrix containing different ratings. A typical collaborative filtering scenario consists of these 2 sets, a set of users and a set of items. And from these 2 sets, we have actually, from ratings given, been able to create this matrix R that contains the different users and the different items and a corresponding rating that a user have given an item. Collaborative filtering aims to take this matrix R and factorize it into 2 different matrices, Q and P, such that when Q and P are multiplied, we get a matrix that is pretty similar to the original matrix R, where the ratings have actually been filled in. And what this actually does for us is that we can estimate the rating of a user U on an item I that he hasn't even rated by multiplying the corresponding rows and columns of the Q and P matrices. Like, for instance, if we want the second item and the second user, we'd take the second row in this Q matrix and the second column in this user matrix. Now this won't really be good values because all of this is just example, but yeah, you get the main idea.
For the data handling aspects of our project, we've created a database based on our datasets from Yahoo. Dataset 1 contains the ratings given to us by Yahoo for artists, and dataset 2 contains the ratings for songs. We've translated each of the tab separated datasets to tables in our database. Most of our queries are based on equality on the user field, so we've created an index for each database based on the user attribute. The predicted ratings table is used to cache the values, the recommendations given to us by Spark, so we don't have to recompute recommendations for a given user each time. So for dataset 1 translates to our Django application to the artist page, so we can see the artist ID and the ratings based on the actual datasets in Yahoo. And to the right, we have predicted ratings that we may or may not have cached in our database.